All right, welcome in everybody. Thank you for joining us here on this Thursday afternoon during your lunch breaks. We appreciate that. We're going to give people a few minutes here just to get settled and let some stragglers roll in before we kick things off. All right, I think we've got a good number in here. If we're ready, Aisha, I'll hand it over to you.
Awesome. Thank you so much. So thank you everybody for joining our webinar on 2026 strategic technology trends for the infrastructure industry. So my name is Aisha Heckel. I'm an innovation engineer here at WGI, and I'm joined by my colleagues Mark Topping and Matt Figge. We are each going to walk you through a technology trend that we see actively reshaping how infrastructure gets planned, built, and operated. We're engineers and practitioners who work in and around these trends every day. So for those of you that don't know or may be less familiar with WGI, we are a national firm celebrating over 50 years of infrastructure solutions with 556 professionals across 24 offices nationwide, and a firm that's actively investing in the technologies that we're talking about today. So being a national firm, we have 24 offices spanning from Florida to Texas to the Midwest and up the East Coast. Our services span the full project lifestyle from transportation and structural engineering to geospatial and land surveying, water and wastewater, planning, architecture, MEP, and many, many more. Which means we're not just looking at these technology trends from the outside, we're integrating them into the work we deliver every day. So I'm going to start us off with looking at robots and physical AI. Matt will follow with 3D printing and construction. Then Mark will cover autonomous vehicles and what they mean for infrastructure planning. And we'll close with a future outlook and how WGI's capabilities connect across all three of these trends. Also, please feel free to enter any questions that you have into the chat as they come up, and we'll answer them all at the end. Awesome. So I will start with the robotics and physical AI, where I'll cover where the industry stands right now with it, where it's headed over the next few years, as well as the real challenges that are still in front of it, and also where WGI fits into that picture. So before I get any further, I want to define physical AI. So this refers to intelligent systems embedded in machines that can perceive and respond to real-world environments. We're not talking about factory robots following a fixed pre-programmed script. We're talking about systems that can navigate an active job site, traverse a bridge underside, or operate inside a confined utility space. So systems that sense their environment, learn from it, and adapt in real time. I've been lucky enough to attend a couple of conferences and see these robots in real life navigate different terrain and then adjust the terrain and see how they respond to these changes. And it's really fascinating to watch. So why is this adoption accelerating right now? There are two things that I see contributing to this. First, the technology itself has matured to the point where the barrier to entry has dropped significantly, and systems that were once only available to the most well-resourced organizations are increasingly within reach for larger firms as well as public agencies. Second, and maybe more importantly, our safety expectations of our industry have risen. Tasks that involve confined spaces, hazardous materials, or high-risk environments are being evaluated differently than they were 5 years ago. When you can deploy an intelligent system to do that work instead of putting a person in that situation, the question shifts from why would we do this to why wouldn't we do it? So we are actively seeing deployment across these three main categories: construction support, things like site layout, reality capture, and material handling, as well as infrastructure inspection, so bridges, tunnels, pipelines, sewer networks, as well as hazardous environments, so confined spaces, utility corridors, chemical areas where you don't want to put people if you can avoid it. And one highlight for this slide is on the inspection side, this is already a $3.6 billion active market in 2026. That is, people are planning for, deploying for, scaling for, and that is very evident. And lastly, I want to highlight this crucial gap that we point out on this slide. Right now, high upfront integration costs mean that early adoption is currently concentrated among larger firms and better funded agencies. While the technology is proven, we do foresee this shifting in the short term. So where the industry is headed. The big highlight on this slide is that robots are evolving from task tools to continuous mobile data collectors. So when a robotic system inspects a bridge or maps a construction site, it's not just completing a task, it's simultaneously generating continuous high-resolution record of that asset's condition. That data doesn't disappear when the robot leaves the site. It feeds directly into the digital twins, asset management platforms, and that is where the compounding value lives. So every future decision about that asset becomes better informed. The robot is building that evidence base. And the future model here is that it's humans plus machine collaboration. So augmentation, not replacement. The people in this field aren't going away. They're being freed up from the dangerous, repetitive, or time-intensive work to focus on judgment, interpretation, and action. So one thing to flag here with our crucial gap note is that data interoperability between platforms from different vendors is a large hurdle. Outputs from systems made by different manufacturers often don't integrate cleanly into existing project workflows without significant customization. So that's a constraint that affects project planning, and we see it fairly regularly. Okay, now the challenges that the industry is working through. So I'm going to rattle off a bunch. Hang on. High upfront integration costs that are limiting broader adoption. While we see that decreasing, it's not fully accessible to everyone in the industry. Plug and play deployment at scale is not here yet. Every site still requires meaningful customization work. Data interoperability gaps between vendor platforms slow down workflows. Change management adds real friction to adoption decisions. And regulatory frameworks for semi-autonomous systems operating in public infrastructure environments are still developing, which creates uncertainty that some clients and agencies are navigating very carefully. So to frame all of these challenges, these are barriers, not deal breakers. They're shaping the pace and pattern of adoption, not stopping it. The question for any agency or firm evaluating this technology today is not whether to engage, but how to engage thoughtfully with the right strategy and the right partners. And then how is WGI positioned? How does WGI interact with this new technology? So let me be very direct about where WGI fits into this and where we don't. As of right now, WGI is not building robots and we're not operating them. WGI's value is in the intelligence and data layer that makes robotic systems useful over time. Our digital service and innovation engineering practice tracks where physical AI intersects with infrastructure delivery. Our geospatial data collection capabilities, our digital twin development work, and our modeling capabilities are directly applicable to the integration challenge that physical AI creates. So the way I would frame it is that WGI provides the digital infrastructure layer that turns robotic data collection into long-term asset intelligence. Whether a client is evaluating robotic inspection for their bridge portfolio, thinking through site automation on a project, or working through a data integration strategy, WGI bridges the gap between what the technology can do and what the outcome really needs to be for any project of any size and any scope. And with that, I'll hand it over to Matt, who's going to walk us through what's happening on the 3D printing side.
All right, hi everyone. I'm going to talk about some exciting new developments in 3D printed building technology. 3D printed buildings are not really new news anymore. The technology's been around for many years, and many of us here today have probably either seen or been inside an actual 3D printed building at some point in our lives. It's actually been around long enough that WGI has provided MEP and architectural services to Icon on multiple projects of varying scale over the last several years. If you aren't familiar, Icon is probably the best known 3D printing company out there, and we've worked on projects ranging from prototype to residential development and even larger scale standalone buildings. So to get a feel for where 3D printing has, or what 3D printing has been able to achieve in recent years, we'll start by showing part of a 2025 CNBC segment on Wolf Ranch, which is a residential development by Lennar and Icon in Georgetown, Texas, north of Austin. You can see that gantry style printers have been the main technology so far. This style of printer is basically a print head on rails that puts down layers of concrete material that build up forms like wall systems and columns. In concept, these printers work the same way as the small 3D printers that you can go online and buy for your home or office. The idea behind 3D printed buildings has always been to make construction more efficient, affordable, resilient, and customizable by feeding your design into a machine that does most of the hard work for you. So while the idea has a lot of potential and has had success, as you can see from this development, scaling it to truly world-changing levels has so far been challenging. So let's talk a little bit about what the limitations are of these gantry-style printers. Perhaps the biggest issue is that print volume is constrained by the height and horizontal extents of the printer's rails. So that typically limits us to printing one story and only wall systems instead of the entire building, like roofs or second stories. Moving and setting up the printers from site to site is time consuming, and print speed is not particularly fast. In addition, a print must be monitored by 3 operators, which means that skilled labor must be on site all times while a machine is running. Design and construction coordination to integrate printed versus non-printed systems takes time, and they're not necessarily an issue for this Wolf Ranch site. It is difficult to maneuver the equipment on tight urban sites, which is why development has so far mostly been done on sites with lots of space, as you can see here. In this video, the leaders of both companies are extremely candid about what they experienced on this project. This development was a bit of a trial. This lady loves her house, by the way. She's great. You should go watch this video later. They're very open about how this development was a bit of a trial in innovation, and some of the lessons they learned along the way informed how they went about executing the project as it continued on. This actually led to the houses being marginally less profitable than Lennar typically sees on its standard project. But the fact remains, this is a real market rate residential development. When a home builder at Lennar's scale adopts a technology, it sends a signal to the rest of the industry that this technology and its potential economic benefits should be taken seriously. And in this case, those benefits are not just production automation, but I would argue that the unique building designs add value as well. As you can see, many of these homes have unique features like curves and other interesting elements that drive value. So here's another video from Adam Savage's Tested. All the challenges that I've discussed previously have led to the need for a next generation of printer. And this printer needs to be easier to use, print taller, and print a more flexible footprint. And as you saw at the beginning of the video, that is Icon's new Titan printer, which is a huge change to an ARM style design. Besides printing bigger and taller, this printer also allows for 2 prints for each mobilization, which basically means you set it up between 2 sites and it can spin around to cover more area without having to move it. According to Icon, this printer is also capable of operating with only two operators instead of three, and it uses newer technology to reduce setup time. All of these improvements serve to reduce the overhead that causes costs to be higher than we would like. And it also, perhaps the biggest impact is that the improved ease of operation allows 3D printing companies to sell these machines to other contractors instead of just producing the buildings themselves. This item has the potential to really quickly increase the adoption of 3D printing throughout the industry and change the economics behind it. This FYI, Icon is currently taking reservations for the Titan with planned delivery in 2027, which is really not that far away. So I look forward to seeing how that goes. So on the next slide, so it's not just Icon doing this around the world. There are several other companies out there producing 3D printers for buildings. And here you see the Maxi printer by a company called Constructions 3D based in France. So you can see that the ARM-based design is emerging as the go-to form factor, though specifics may vary slightly from printer to printer. This printer, for example, has a more spider leg base than the Titan and is geared toward portability. You can see it getting set up and going to work here. There it goes. All right, you can go to the next slide. And it's not just machinery that's advancing either. Materials research is ongoing as well. One big challenge has always been inserting rebar reinforcement into layer-based prints. And Carnegie Mellon's Computational Engineering and Robotics Lab has been experimenting with spray-based applications that would apply material directly onto formed rebar. If this research pans out, it could unlock a huge number of new architectural and structural use cases where 3D printing is currently not possible. So let's tie it all back to how this impacts WGI as a professional services firm. As I mentioned at the beginning, the team at WGI has worked with Icon on several projects. And what we've seen is that there needs to be an extra level of consideration for data in order to maximize the impact of automated construction. These machines are only as good as the data that gets fed into them. So the big question becomes, how quickly and efficiently can we get from a design model to machine input? Our team produces high-fidelity BIM models that feed into Icon systems, and while model geometry and standard takeoffs remain important because we still have to create 2D drawings for permanent construction, the data representing that geometry is even more important. Our VDC and innovation teams have created automation tools and data extraction strategies alongside our models that go 1 or 2 layers deeper than we would on a traditional project. And this helps the design team and our client Titan design to print workflows that better harness the technology's potential. So my experience working on 3D printed projects, it has honestly been awesome to see how we've been able to leverage technology to help eliminate the gaps between what we put on paper and what these printers create in real life. And I know that we're all excited by where this next generation of printing technology is poised to take us. And with that, that's all I know about 3D printing. With that, I'll kick it over to Mark, who's going to talk about autonomous vehicles.
Thank you, Matt. Very interesting. My name is Mark Topping. I'm a client solutions manager with WGI's geospatial division. We specialize in using multiple data sources, remote sensing, surveying, subsurface utility engineering to support data to design off of and to produce as-built models off of for a wide range of applications, from transportation to utility infrastructure and beyond in a wide range of environments. That's what we kind of specialize in. Aisha highlighted earlier in the robotics section that we are not yet collecting geospatial data directly with robotics, but we are headed that direction and directly engaged with producing and surveying geospatial information that supports infrastructure in the advent of of autonomous vehicles. So let's jump into it. We'll talk about the AV ecosystem. Of course, everyone's mind would likely jump to self-driving cars when they think of the term autonomous vehicles. That is certainly a large factor in designing infrastructure around self-driving cars. Keep in mind, there's a lot of similar technologies that self-driving cars use themselves. Because they need awareness of their environment to safely operate. Self-driving cars utilize often multiple LiDAR scanners. So LiDAR is a technology that collects 3D spatial information around a sensor based on the reflection of light and the timing to very precisely measure objects around a LiDAR scanner. Photogrammetry methods are also used in self-driving cars. Mr. Elon Musk and Tesla have, sort of adopted the photogrammetry model for Tesla vehicles. But autonomous vehicles goes well beyond self-driving cars. WGI is a supporting engineering firm and a geospatial service specialist with a highlight in diversity of data and information, are starting to see the advent of other automation. For example, vertical takeoff and landing drones, which is the eVTOL acronym you're seeing on the screen, and heavy lift drones, having the capability to move large freight and people. So what does that mean for infrastructure, the challenges in developing infrastructure that can support the advent of autonomous vehicles? I'm going to highlight the geospatial standpoint. So first of all, the need for higher quality and more diverse geospatial data. This involves not only mapping and performing engineering in 2D, but doing so in 3D with higher resolutions, higher accuracies, and also including features above and below the ground, subsurface utilities, as well as terrestrial, and above and below water. So that's bathymetric inputs. Data governance and strategy. As we have more diverse sources of geospatial data collecting, the question becomes, how do we standardize this? How do we manage all this data? And how do we use it effectively? So that's a large topic that's involved with quality and metadata, creating standards for evolving geospatial services that support infrastructure design in the modern world. Another topic is data relevance and access. So we've all heard the 3D term. I'm going to introduce a term 4D, which is a temporal addition to data. So when it was collected, when it was accurate to an as-built environment, as we migrate towards real-time geospatial intelligence. Also the use cases of these solutions, a wider range of applications beyond the traditional, serving in mapping and, emergency response, elevation mapping, some of the common traditional uses of geospatial intelligence and GIS, and actually vetting these value-added solutions. So the industry is working on early deployments for infrastructure that supports autonomous vehicles. One example is Suntrack's facility in Central Florida, where FDOT has established testing and R&D for transportation infrastructure materials, as well as self-driving vehicles and public-private sector partners. And they are working towards building, supporting advanced air mobility at Suntracks and exploring and researching the advent of advanced air mobility, which is autonomous aerial vehicles deploying from vertiports, as you're seeing in the right of your screen. Let's move to the next slide, please. So here's a good example of WGI's support role in developing infrastructure that supports research on advanced air mobility. In this case, ideally, the end goal is to reduce congestion through the I-4 corridor between Tampa and Orlando, and allow for additional benefits like safety, transportation efficiency, and congestion reduction as the Orlando area continues to grow. It should be noted that regulatory compliance is being developed for autonomous aerial vehicles. The FAA has their Part 108, which is a heavy lift drone operations for carrying heavy cargo and potentially humans. So that is an ongoing consideration is the regulatory environment for Part 108 and the FAA. I'll jump quickly into WGI's role in this project at Suntrex. We used multiple data sources from aerial remote sensing to terrestrial mobile scanning, and all tied into a uniform control network where we collected a very diverse and high quality range of geospatial data to map and model every inch of the facility, perform a high fidelity design survey, and produce a 3D building information model of the facility for future development, airspace considerations, environmental considerations as infrastructure is built to support advanced air mobility. Next slide, please. So as we wrap up this presentation, I'd like to look at the future of infrastructure technology, sort of tying all three of these threads together. The common denominator across robotics, 3D printing, and autonomous vehicles is digital maturity, digital delivery, and standardization of those digital products. That's really the foundational layer of developing all three of these emerging trends. Integration of systems, expedition of near real-time data, so that we can support a more rapid deployment of these technologies. They're not necessarily parallel tracks, but they're converging. Robots generate data that feed digital twins. Digital twins inform AV-ready infrastructure planning, and 3D printing requires the same precision in digital layers for its design and printing of 3D infrastructure. We'll highlight a quote. If we could just jump back really quick there, Christina. We'll highlight a quote from WGI's president in the bottom of your screen, where we're highlighting the need to make regulatory and technical decisions now that support the future of the AEC industry. Before we know it, the progression of these trends is doing nothing but accelerating. So it's critical that we use this time now to plan accordingly. Key takeaways regarding robotics. I'd like to highlight augmenting capacity, supporting efficiency, moving personnel to a quality and management role, as well as generating critical data, which is foundational to long-term asset management using robot collected data. 3D printing, commercial deployment is here for the right applications, as Matt demonstrated. And the digital prerequisites are important as the printers themselves. These two technologies and the regulatory requirements and organization go hand in hand. Lastly, on autonomous vehicles, this is an infrastructure systems challenge as much as a vehicle technology challenge. What we're seeing is the data is there. We have data. It's the organization and the use of the data that's critical. And regarding WGI, WGI delivers integrated digital services for infrastructure of any size and scope nationwide. The breadth matters are between our geospatial, innovation, engineering, transportation planning. WGI provides services from design and survey to ribbon cutting of projects, and we specialize in innovation that support efficiencies and safety. And with that, I will pass it back to our moderator for mention of the white paper and questions.
Thank you, Mark. That was fantastic, guys. Great job. Want to wrap up here. If anyone is interested in learning more about the technology trends for the infrastructure industry, we produced a white paper where all three of your presenters here are stakeholders. We've covered 6 additional trends in this paper, so if you're interested in getting a copy, there's a QR code right there on the screen. We'll give you a chance to take a picture of it and download our paper. If anybody has any questions, please feel free to drop those in the Q&A section of the team's presentation here, and we will rattle those off to our presenters and they'll give you a great answer. I think we have one before we get started in here. Mark, if you want to talk a little bit about some of the challenges, maybe big picture items that the industry is facing when trying to move in towards these trends. I know you can talk more about the AV side, the geospatial side, but what are some of the challenges that the industry is going to be facing when trying to move into some of these trends?
Yeah, the critical stakeholders, often government, are being, driven towards more data, higher quality data, and efficiencies in collecting that data. We're seeing certainly some redundancy in the collection of source data, varying standards of the data, varying metadata that supports quality and documentation of the source of the data. So we're seeing larger government entities being asked to collect and standardize these things and kind of take it to a next level to support more and more applications. So it's critical that higher quality and diverse geospatial data is fully understood and documented, and that these entities that manage the source data for these projects have a data governance strategy and clearly defined standards, as well as validation of the use cases of the data. Some data is good enough for certain things and not others.
It's a good explanation. Thank you, sir. We'll give a few more seconds here for anybody that has any questions at the moment to drop them into the Q&A. Also, if you look on your screen now, you're going to see emails for each of our presenters here. If you have any questions that you don't want to ask in the session, feel free to mark those down and you can ask the questions to them directly. We're also going to be following this up on Friday with a follow-up to everyone that attended here with the recorded session, as well as more contact information for you to reach out to our presenters. I don't see any more questions in the Q&A, so I'm just going to wrap everything up here. We appreciate everyone joining us today. Thank you to our presenters for a wonderful presentation. Like I said, we'll follow this up on Friday with a recap of everything we went over. If you need anything at all, feel free to reach out to one of our presenters directly. Thanks, guys.
Thank you.
Thank you.